Voyager 1 has been humanity's most distant messenger for over 4 decades, traveling through the cosmic void at 38,000 miles per hour and sending back data from regions no human has ever seen. But here's what will blow your mind. This 1970s spacecraft, built with less computing power than your smartphone, just detected something moving in interstellar space that has NASA scientists working around the clock to understand what they're looking at. The mysterious signal. Voyager 1 just sent back data that has NASA scientists working around the clock, and what they discovered 14 billion miles from Earth is keeping them awake at night. Deep in the cosmic void where no sunlight has touched anything for billions of years, something is moving with purpose and intelligence that defies every law of physics we understand. The signal first appeared as an anomaly in Voyager's plasma wave readings, a rhythmic pattern that shouldn't exist in the empty darkness between stars. But here's what's really unsettling. When scientists ran the data through every possible filter and diagnostic test, they realized this wasn't equipment failure or cosmic interference. This was something real, something structured, and something that seemed to be tracking Voyager's movement through space. The electromagnetic signature doesn't match any known celestial phenomenon, and its behavior patterns suggest a level of complexity that has researchers questioning everything they thought they knew about interstellar space. What makes this discovery even more extraordinary is that the signal appears to be responding to Voyager's presence, almost as if it recognizes the spacecraft as something foreign in its domain. For the first time in human history, we may have encountered something in the depths of space that operates by rules we haven't discovered yet, and it's been watching us from the shadows of the cosmos. Voyager's journey beyond the planets. Right now, as you're watching this video, there's a piece of human technology hurtling through absolute darkness at 38,000 miles per hour, farther from home than any object in human history. Voyager 1 crossed the boundary into interstellar space in 2012, becoming humanity's first ambassador to the galaxy beyond our solar system. But here's what most people don't realize. This region was supposed to be cosmic wasteland, a barren void containing nothing but scattered hydrogen atoms and ancient starlight. Instead, Voyager has been sending back data that's completely rewriting our understanding of what exists in the space between stars. The spacecraft is now over 14 billion miles from Earth, traveling through a realm where our sun appears as just another faint star and temperatures hover mere degrees above absolute zero. This is a place where radio signals from Earth take over 22 hours to reach Voyager, and every piece of data it sends back is like a message from another dimension. What makes this journey even more remarkable is that Voyager was never designed to survive this long or travel this far. It was built for a 4-year mission to Jupiter and Saturn. Yet here it is, decades later, exploring the cosmic frontier and discovering that interstellar space is far more dynamic and mysterious than we ever imagined, setting the stage for encounters that challenge everything we thought we knew about the universe. Unexpected movement detected. Something is defying the laws of physics in the coldest, emptiest region of space, and it's moving in ways that have scientists questioning everything they thought they knew about how objects behave in the cosmic void. The movement Voyager detected wasn't the predictable drift of space debris or the gravitational dance of celestial bodies. This was something actively changing course, accelerating and decelerating with patterns that looked disturbingly intentional. When the data first arrived at Mission Control, engineers thought they were looking at corrupted telemetry because objects simply don't behave this way in interstellar space. But after months of analysis and verification, they realized they were witnessing something unprecedented, an object that seemed to be making deliberate course corrections billions of miles from the nearest star. The movement patterns showed periodic velocity changes that couldn't be explained by solar wind, magnetic fields, or gravitational influences from distant stars. What's even more unsettling is that the object appeared to be adjusting its trajectory in response to Voyager's approach, almost as if it was aware of the spacecraft's presence and reacting accordingly. Scientists have run the data through every known model of celestial mechanics, and nothing comes close to explaining what they're seeing. This isn't random motion or natural orbital mechanics. This is controlled movement in a region of space where nothing should be able to control anything, challenging our fundamental understanding of what's possible in the vast emptiness between stars. Not a planet, not a comet. Every single explanation in our cosmic playbook has been crossed off the list, and what remains is something that shouldn't exist according to everything we know about space. Scientists have spent months systematically eliminating every possible conventional explanation for this mysterious object, and each elimination has only deepened the mystery. Planets don't roam freely through interstellar space, and even the rare rogue planets that get ejected from their star systems follow predictable gravitational trajectories that this object completely ignores. Comets are ruled out because they develop distinctive tails and comas when exposed to stellar radiation. But there are no stars within light-years of this object's position to trigger such activity. The spectral analysis shows none of the rocky signatures we'd expect from an asteroid, and its complex movement patterns are far too sophisticated for a simple chunk of space debris drifting through the void. Even exotic celestial bodies like brown dwarfs, neutron stars, and white dwarfs have been eliminated because this object doesn't emit the characteristic radiation signatures that would identify it as any known type of stellar remnant. What's left is something that behaves unlike any natural phenomenon we've cataloged in our centuries of astronomical observation. The object's ability to change course, its apparent awareness of Voyager's presence, and its structured movement patterns have pushed scientists into uncharted territory where conventional astrophysics offers no answers, forcing them to consider possibilities that challenge the very foundations of what we believe exists in the cosmos. Theories behind the movement. The world's leading astrophysicists are proposing theories that sound more like science fiction than peer-reviewed research, and that alone should tell you how extraordinary this discovery really is. One of the most compelling hypotheses suggests we might be witnessing our first direct encounter with dark matter structures that interact with normal matter in ways we never predicted, creating movement patterns that appear almost biological in their complexity. Another theory proposes that this object represents evidence of exotic physics operating on scales we've never observed before, possibly involving magnetic field interactions or quantum effects that only manifest in the extreme conditions of interstellar space. Some researchers have suggested we might be looking at a completely new type of celestial body formed by processes that don't exist anywhere in our solar system, perhaps created by the collision of cosmic phenomena we haven't discovered yet. The most controversial theory, whispered in academic circles but rarely published, is that we might be observing technology of non-terrestrial origin, something that operates by principles we haven't mastered or even understood. What makes this theory particularly unsettling is that the object's behavior patterns show characteristics that some researchers find impossible to explain through any known natural phenomenon. The structured movement, the apparent responsiveness to Voyager's presence, and the sophisticated course corrections all point to something that operates with a level of complexity that challenges our understanding of what's possible in the vast emptiness between stars. Voyager's instruments and their role. 47-year-old technology designed during the Nixon administration is currently making the most groundbreaking discovery in human history. And the irony isn't lost on the scientists analyzing the data streaming back from the edge of known space. Voyager's scientific instruments, built with 1970s computing power that's millions of times less sophisticated than your smartphone, have somehow become humanity's most advanced deep space detective system. The plasma wave instrument has been crucial in detecting the electromagnetic signatures that seem to pulse in rhythm with the mysterious object's movements, creating patterns that resemble communication more than random cosmic noise. Meanwhile, the magnetometer has revealed magnetic field fluctuations that correlate perfectly with the object's position changes, suggesting it's either generating its own magnetic field or manipulating the existing interstellar medium in ways we've never observed. Most remarkably, the cosmic ray detector has shown that this object is somehow creating a shadow in the cosmic radiation background, deflecting high-energy particles in a manner that suggests it has mass and structure far beyond what its other signatures would indicate. These instruments weren't designed to detect artificial objects or analyze unknown phenomena. They were built to study planets and measure solar wind. Yet they're providing us with data about something that operates by rules we haven't discovered, proving that sometimes the most extraordinary discoveries come from tools we never expected to make them. The distance and speed of the object. At this very moment, something is racing through the cosmic void at speeds that would make our fastest rockets look like they're standing still, operating in a region of space so remote that light from our sun becomes just another dim star in an ocean of darkness. The object was first detected when it was approximately 500 million miles from Voyager 1, which means it's functioning in a zone where the nearest star system is still over 4 light-years away, a distance so vast that even traveling at the speed of light, it would take 4 years to reach the closest stellar neighbor. What's absolutely mind-blowing is that this object has been clocked moving at roughly 26,000 miles per hour, relative to Voyager's position. But here's where it gets really weird. That speed isn't constant. The object has been observed accelerating and decelerating in patterns that suggest it's not just drifting through space like a piece of cosmic debris. To put this in perspective, even our most advanced spacecraft would require tens of thousands of years to cover the distances this mysterious object has traveled. Yet it's doing so while making controlled course corrections that defy everything we know about how objects move through interstellar space. The fact that something can demonstrate such apparent control over its movement at these incomprehensible distances and speeds raises profound questions about what we're actually witnessing in the deepest, darkest corners of our galaxy. Why scientists are intrigued. The most brilliant minds in astrophysics are losing sleep over data that's honestly forcing them to question 40 years of established science. Some are even privately admitting they might need to rewrite the textbooks on what actually exists in interstellar space. This discovery isn't just another interesting anomaly that scientists can, file away and study later. It's actively challenging fundamental assumptions about the very nature of the cosmos that have guided space exploration for decades. For generations, we've operated under the comfortable assumption that the vast regions between stars are basically empty highways, where objects follow predictable paths governed by well-understood gravitational forces. But this mysterious object is behaving like it has its own agenda, moving with a kind of purpose and intelligence that suggests interstellar space might be way more populated and active than we ever dared to imagine. What's really keeping researchers awake at night is the realization that if one object like this exists, there could be thousands or even millions of similar phenomena operating in the cosmic shadows, completely undetected by our Earth-based telescopes. The implications here are just staggering. We might be living in a universe that's absolutely teeming with activity we've never noticed, surrounded by phenomena that operate by physical laws we haven't even discovered yet. This single detection has opened a door to possibilities that range from revolutionary physics to, honestly, the unsettling prospect that we're not alone in ways we never considered, fundamentally changing how we view our place in the cosmic order. Potential implications for space exploration. The discovery that's currently sitting on classified desks at NASA headquarters could, completely revolutionize how we design spacecraft and plan missions to the stars. The implications are so profound that space agencies around the world are quietly restructuring their long-term exploration strategies. If this mysterious object represents a new category of interstellar phenomena, it means that the space between stars is far more complex and potentially hazardous than we've been preparing for, forcing engineers to totally rethink how future deep space probes will navigate and survive in regions we thought were predictably empty. The object's apparent ability to manipulate its environment and respond to external stimuli suggests that interstellar space might contain active systems that could either help or hinder human exploration efforts in ways we never really anticipated. From a technological standpoint, understanding the physics behind this object's movement capabilities could unlock propulsion concepts that would make our current rocket technology look, honestly, pretty primitive, potentially reducing interstellar travel times from tens of thousands of years to mere decades. Even more intriguing is the possibility that this discovery could lead to breakthroughs in energy manipulation and field generation that would revolutionize not just space travel, but technology here on Earth as well. The fact that we stumbled upon this phenomenon by accident just highlights how much we still don't know about our cosmic neighborhood, suggesting that future missions equipped with more advanced detection systems might encounter similar objects regularly, fundamentally changing our approach to exploring the galaxy and our understanding of what's possible in the vast ocean of space surrounding our solar system. What could it really be? After exhausting every conventional explanation and running the data through every known model of physics, we're left staring at three possibilities that would each, honestly, fundamentally change humanity's understanding of our place in the universe. The most conservative scientific explanation suggests we've discovered a completely new type of interstellar object. maybe a category of celestial body formed by exotic processes that don't exist anywhere in our solar system, operating by physical laws we haven't identified yet. A more radical possibility is that we're witnessing our first direct encounter with dark matter structures that can interact with normal matter in ways our current theories never predicted, creating organized movement patterns that appear almost alive in their complexity. But here's the explanation that's being whispered in research facilities around the world, the one that keeps appearing in classified reports. Despite scientists' reluctance to discuss it publicly, we might be observing technology of non-human origin. The object's structured movement patterns, its apparent responsiveness to Voyager's presence, and its ability to make controlled course corrections in the vast emptiness of interstellar space, all point to something that operates with a level of sophistication that, honestly, challenges every assumption we've made about what exists in the cosmic void. Regardless of which explanation proves correct, this discovery represents a watershed moment in human history. The moment we realize that the universe is far stranger, more populated, and more mysterious than we ever dared to imagine, forcing us to confront the possibility that we're not alone in ways we never considered. So there you have it, Voyager's incredible discovery that's honestly challenging everything we thought we knew about interstellar space. Whether this mysterious object represents unknown physics, a new type of celestial phenomenon, or something even more extraordinary, one thing is certain: we're living through a moment of genuine cosmic mystery. What's your theory on what this object could be? Drop your thoughts in the comments below. I really love hearing your perspectives on these space mysteries. If you enjoyed diving into this cosmic puzzle, make sure to subscribe to Simply Science and hit that bell icon so you never miss our latest discoveries from the final frontier. Thanks for exploring the universe with us. In September of 2022, humanity officially became a cosmic force, capable of moving celestial objects through space. But what happened next, honestly, shocked even NASA's top scientists. When the DART spacecraft slammed into asteroid Dimorphos at 14,000 miles per hour, it didn't just nudge the space rock as planned. The impact created a 32-minute orbital change instead of the expected 10 minutes, proving our planetary defense technology is 3 times more powerful than we ever imagined. We didn't just deflect an asteroid, we revolutionized physics itself. The DART mission. What if I told you that on a Tuesday morning in September 2022, humanity officially became a space cowboy? That's exactly what happened when NASA's DART spacecraft smashed into asteroid Dimorphos at over 14,000 miles per hour, marking the first time our species deliberately changed the course of a celestial object. This wasn't just another space mission, this was our planetary defense debut. The double asteroid redirection test launched in November 2021 with one clear mission: prove we could knock an asteroid off course if one ever threatened Earth. Scientists chose Dimorphos, a football stadium-sized moon orbiting the larger asteroid Didymos, as the perfect target. Why? Because it was far enough away to be safe but close enough for telescopes to measure the results. The $325 million mission spent nearly a year traveling through space, guided by autonomous navigation systems that would steer the spacecraft into its target without human intervention. On September 26, 2022, at exactly 7:14 p.m. Eastern Daylight Time, DART completed its kamikaze mission, streaming live images back to Earth until the very moment of impact. Ground control erupted in cheers as confirmation arrived. Humanity had just taken its first real step toward becoming a spacefaring civilization capable of defending our home planet from cosmic threats. Impact results analysis. You know that moment when you throw a rock into a calm pond and watch the ripples spread? Well, multiply that by about 10 billion and you'll get close to what happened when DART hit Dimorphos. The moment of impact on September 26, 2022 created the most spectacular light show in our solar system, a massive debris plume that stretched over 10,000 kilometers into space, visible to telescopes across the globe. But here's the mind-blowing part. This wasn't just a little puff of dust. The impact crater ejected millions of tons of rock and debris at speeds reaching 500 meters per second, creating what scientists called a comet-like tail that persisted for months. Ground-based observatories and the Hubble Space Telescope captured breathtaking images, showing the asteroid system glowing like a distant star. The brightness increase was so dramatic that Dimorphos became 35 times brighter than normal, making it visible to amateur astronomers with basic equipment. What shocked researchers most was the duration of the debris cloud. Initial models predicted it would dissipate within days, but observations in November 2022 still showed active particle ejection. The European Southern Observatory tracked individual boulders the size of cars being hurled into space, while NASA's infrared telescopes detected the heat signature of the impact site glowing for weeks afterward. This spectacular aftermath proved that kinetic impact missions create far more dramatic and long-lasting effects than anyone had calculated. Momentum enhancement discovery. Scientists expected a gentle nudge. What they got was a cosmic sledgehammer effect that rewrote the laws of asteroid physics overnight. When NASA's mission planners originally calculated DART's impact, they predicted the collision would slow Dimorphos by exactly 10 minutes in its 11.9-hour orbit around Didymos. Conservative estimates based on laboratory simulations and computer models suggested this would be humanity's modest first step into planetary defense. But on October 11, 2022, when ground-based radar measurements finally confirmed the results, jaws dropped across the scientific community. The asteroid's orbital period had decreased by a staggering 32 minutes, more than triple the expected change. This wasn't just beating expectations, this was obliterating them. The momentum transfer efficiency reached 2.2 to 4.9 times higher than theoretical predictions, depending on which measurement method scientists used. Dr. Lori Glaze from NASA's Planetary Science Division called it a game-changing discovery that fundamentally altered our understanding of kinetic impactor technology. The reason? Dimorphos wasn't behaving like a solid rock, but more like a loose aggregate of boulders held together by weak gravity. When DART struck at 6.14 kilometers per second, it didn't just transfer its momentum, it triggered a massive recoil effect, as tons of debris shot out like a natural rocket thruster. This ejecta enhancement meant that future asteroid deflection missions could work with much smaller spacecraft than previously thought, revolutionizing our entire approach to planetary defense. Asteroid structure insights. Ever wondered what happens when you punch a pile of gravel versus a solid brick wall? That's exactly what DART's collision revealed about Dimorphos, and honestly, it completely shattered our assumptions about asteroid composition. Before September of 2022, scientists believed most asteroids were dense, rocky bodies that had formed billions of years ago during the early solar system. But when DART slammed into Dimorphos at 14,000 miles per hour, the impact didn't create the expected solid crater. Instead, it triggered what researchers called a catastrophic disruption that exposed the asteroid's true nature as a gravitationally bound rubble pile. High-resolution images from ground-based telescopes showed massive boulders, some the size of school buses, being ejected from the impact site, revealing that Dimorphos is essentially a loose collection of rocks held together by extremely weak gravitational forces. This discovery revolutionized our understanding of near-Earth objects, with Dr. Andy Rivkin from Johns Hopkins Applied Physics Laboratory confirming that 80% of asteroids in our cosmic neighborhood share this rubble pile structure. The implications are, well, staggering. These flying gravel heaps are much easier to deflect than solid asteroids, but they're also way more unpredictable in how they respond to impacts. Spectroscopic analysis conducted in late 2022 revealed that the ejected material contained primitive carbonaceous compounds dating back 4.6 billion years, making Dimorphos a time capsule from the solar system's violent birth. This insight means future deflection missions will need completely different strategies depending on whether they're targeting solid asteroids or these cosmic rubble piles. Strategic implications. What happens when humanity suddenly realizes it can literally move mountains in space? The moment DART's success was confirmed in October 2022, every space agency on Earth started rewriting their planetary defense playbooks. This wasn't just a scientific achievement, it was a species-level upgrade that transformed us from sitting ducks to active defenders of our cosmic neighborhood. The 32-minute orbital change proved that kinetic impactor technology could work with dramatically smaller spacecraft than previously calculated, meaning we could launch multiple deflection missions for the cost of one original estimate. NASA's Planetary Defense Coordination Office immediately began updating their threat assessment protocols, realizing that asteroids once considered too large to deflect were now manageable targets. But the implications go far beyond just Earth protection. International space treaties from the 1967 Outer Space Treaty suddenly needed modernization. Who has the authority to deflect an asteroid that might affect multiple countries? ESA's Director General Josef Aschbacher announced in early 2023 that the success had accelerated European Union space defense initiatives by at least 5 years. Meanwhile, China's National Space Administration and Russia's Roscosmos both fast-tracked their own asteroid deflection programs, creating a new space race focused on planetary protection rather than exploration. The most surprising strategic shift came from commercial space companies like SpaceX and Blue Origin, who began developing rapid response deflection systems that could be deployed within 18 months of asteroid detection, turning planetary defense from a decades-long project into something resembling an emergency response system. We officially entered the era where extinction-level threats became manageable engineering problems. Hera mission planning. What do you do when you've just pulled off humanity's greatest cosmic billiard shot and need to see the damage up close? You send in the forensic investigators. That's exactly what ESA's Hera mission represents, a $129 million space detective story launching in October 2024 to examine DART's crime scene with unprecedented detail. While DART was the muscle, Hera is the brains, equipped with advanced imaging systems and 2 CubeSat companions called Juventus and Milani that will map every crater, boulder, and debris trail left behind by the September 2022 impact. The mission will spend 2 years traveling to the Didymos system, arriving in late 2026 to conduct the most thorough asteroid autopsy in human history. Hera's instruments include high-resolution cameras, laser altimeters, and ground-penetrating radar that will create 3-dimensional maps showing exactly how Dimorphos deformed during impact. But here's where it gets fascinating. Juventus will actually land on Dimorphos and drill into its surface, analyzing the internal structure that made DART's momentum transfer so surprisingly effective. Meanwhile, Milani will study the dust environment and track particles still orbiting the asteroid system 4 years after impact. ESA's mission planners designed Hera to answer the biggest question: can we scale up this technology for real planetary threats? The data collected will feed directly into NASA's next-generation deflection systems, creating a complete blueprint for asteroid defense architecture. When Hera arrives at Didymos, it won't just be studying the past, it'll be engineering humanity's cosmic security system for the future. Planetary defense evolution. Remember when humanity's biggest space worry was whether satellites would crash into each other? Those days, honestly, officially ended when DART proved we could weaponize physics itself against cosmic threats. The September 2022 success didn't just validate one mission, it triggered a complete evolutionary leap in how our species approaches planetary defense. Within months of impact confirmation, space agencies worldwide began developing second-generation deflection technologies that frankly make DART look like a prototype. NASA's follow-up missions now include multiple kinetic impactors working in coordinated strikes, gravity tractors for precision orbit adjustments, and even nuclear pulse units for the most extreme scenarios. Japan's JAXA announced their 2028 Hayabusa X mission will test precision drilling techniques to alter asteroid rotation, while India's ISRO is developing swarm deflection technology using dozens of small spacecraft acting as a collective force. The most revolutionary change, though, came from private sector involvement. SpaceX began designing Falcon Heavy variants specifically for rapid asteroid response, cutting deployment time from years to months. ESA's 2025 Planetary Defense Conference established the International Asteroid Response Protocol, creating standardized procedures for global cooperation during real threats. But perhaps the biggest evolution is philosophical. We've shifted from reactive astronomy to proactive cosmic engineering. Ground-based surveys like NASA's NEO Surveyor and ESA's FlyEye telescopes now operate as early warning systems feeding directly into automated deflection networks. What started as humanity taking its first baby steps into planetary defense has evolved into a sophisticated cosmic immune system that actively monitors and neutralizes threats before they become extinction events. Mission success redefinition. When was the last time scientists had to completely rewrite what winning means in the middle of celebrating victory? Well, that's exactly what happened when DART's results came back showing a 32-minute orbital shift instead of the predicted 10 minutes. Suddenly, every planetary defense mission in development had to recalibrate their success metrics. Before October 2022, mission planners used these pretty conservative models based on solid asteroid physics and laboratory impact tests that assumed only modest momentum transfer rates. NASA's original benchmarks actually classified anything above 73 seconds of orbital change as a complete success, making DART's 32-minute achievement an almost 2,600% overperformance. This unexpected triumph forced JPL engineers to completely revise their deflection calculators and threat assessment algorithms. Dr. Tom Statler from NASA headquarters even admitted that success parameters for future missions like ESA's Hera and NASA's proposed NEO interceptor needed fundamental restructuring. The ripple effects were immediate asteroid deflection timelines that once required decades of advance warning could now work with just years of preparation. International space law committees had to redefine minimum deflection requirements for planetary protection protocols, while commercial space contractors realized they could bid for asteroid deflection contracts using much smaller, cheaper spacecraft. Most importantly, the scientific community learned that real-world asteroid physics operated on completely different principles than computer simulations suggested. Mission success was no longer about hitting predetermined targets. It was about adaptive engineering that could harness these unexpected physical phenomena. DART didn't just succeed, it redefined success itself, proving that sometimes the best victories are the ones that exceed every prediction and force humanity to dream bigger. Debris management and safety concerns. What happens when you create the largest artificial debris field in human history and suddenly realize it might come back to haunt you? That's the uncomfortable question NASA scientists faced when DART's impact on September 26, 2022 scattered millions of tons of asteroid fragments across space at velocities reaching 500 meters per second. While everyone celebrated the 32-minute orbital success, space debris experts quietly began tracking what they called the Dimorphos particle cloud, an expanding sphere of rocky projectiles that could pose risks to future spacecraft missions. ESA's Space Debris Office immediately activated enhanced tracking protocols using ground-based radar systems to monitor the largest fragments, some weighing several tons and traveling on unpredictable trajectories. The October 2022 debris analysis revealed that particles were spreading far beyond the Didymos system, with some fragments potentially reaching Earth-crossing orbits within decades. Commercial satellite operators like SpaceX and OneWeb began incorporating DART debris models into their collision avoidance systems, while NASA's Orbital Debris Program Office updated their space traffic management protocols to account for artificial asteroid fragmentation. The most concerning discovery came in early 2023 when optical telescopes detected boulder-sized chunks still being ejected from Dimorphos months after impact, suggesting the asteroid was experiencing ongoing structural collapse. International Space Station mission planners now include DART debris assessments in their orbital safety calculations, and future asteroid deflection missions must prove they won't create navigational hazards for deep space exploration. The irony is pretty striking. Humanity's first successful planetary defense created our first interplanetary pollution problem. Precision requirements for real threats. What good is humanity's newfound cosmic billiard skills if we can't hit the balls that actually matter? While DART's triumph against Dimorphos was spectacular, deflecting a real Earth-threatening asteroid requires precision levels that make Swiss watchmaking look like finger painting. The sobering reality hit scientists in early 2023 when they calculated the exact requirements for real planetary defense scenarios. Unlike Dimorphos, which was a harmless test target 11 million kilometers away, an actual extinction-level asteroid would need deflection decades before impact, and missing by even 0.01% could mean the difference between a near miss and global catastrophe. NASA's Planetary Defense Office revealed that successful deflection of a 1-kilometer asteroid discovered just 10 years before Earth impact would require trajectory accuracy within 10 meters at the moment of collision. Imagine threading a needle while blindfolded and riding a rocket. The challenge multiplies when dealing with fast-rotating asteroids or binary systems like Didymos, where gravitational interactions can amplify small errors into massive miscalculations. ESA's trajectory modeling in 2024 showed that deflecting Apophis during its 2029 close approach would demand navigation precision exceeding anything achieved in human spaceflight history. Perhaps most daunting, detection systems like NASA's NEOWISE and the upcoming NEO Surveyor must provide asteroid composition data, rotation periods, and structural characteristics years in advance because with real threats there are no second chances. DART proved we can move asteroids, but defending Earth means hitting cosmic bullseyes with zero margin for error. And that's how humanity officially became cosmic defenders in just one incredible impact. From DART's sledgehammer effect to the 32-minute orbital miracle, we've proven that extinction-level threats are now manageable engineering problems. But this is just the beginning of our planetary defense evolution. What amazed you most about DART's discoveries? Drop your thoughts in the comments below. I read every single one. If this blew your mind like it did mine, smash that subscribe button and hit the bell icon so you never miss Simply Science breaking down the universe's most incredible mysteries. Until next time, keep exploring. A rare visitor from deep space is flying through our solar system, and this one is, honestly, mind-blowingly mysterious. 3I Atlas came from beyond our solar system, making it only the third confirmed interstellar object ever discovered. But, new data from NASA and international observatories suggests this ancient traveler might be something far more extraordinary than just another comet racing past the sun. The breaking discovery. On July 1, 2025, astronomers using the NASA-funded Asteroid Terrestrial Impact Last Alert System telescope at Rio Hurtado, Chile, made a breakthrough discovery that would, captivate the global scientific community. They detected a moving object initially designated as A11PL3Z, later confirmed as 3I Atlas, representing the third known visitor from beyond our solar system. This rapid confirmation was achieved through combined efforts of international observers, including the Minor Planet Center and researchers at NASA's Jet Propulsion Laboratory. The object's initial detection proved challenging due to its faintness and location near dense star fields close to the galactic center in the constellation Sagittarius. High-precision astrometric measurements soon revealed its distinctive hyperbolic trajectory and extreme velocity, definitively eliminating the possibility it belonged to our solar system. 3I Atlas's discovery immediately energized astronomers worldwide, sparking an unprecedented campaign of rapid, coordinated observations designed to track this rare interstellar visitor, while maximizing data collection before it became too dim to observe effectively. This extraordinary find underscores the remarkable capabilities of modern telescopic survey systems in uncovering objects once believed completely undetectable, opening new scientific horizons for comprehensive interstellar object research. The discovery story. Between June 25 and 29, 2025, the ATLAS survey system, composed of 4 powerful telescopes strategically located in Hawaii, Chile, and South Africa, captured multiple critical detections of the newly discovered object, now officially known as 3I Atlas. The initial observational data appeared as extremely faint streaks against the dense starry backdrop, but gained tremendous scientific significance as coordinated follow-up observations quickly pinpointed its precise celestial path. Simultaneous observations from the Zwicky Transient Facility at Palomar Observatory in California, strongly supported by dedicated researchers like Marco Micheli from the European Space Agency and Daryl Seligman from Michigan State University, helped definitively confirm the object's unbound hyperbolic trajectory, providing compelling evidence supporting its confirmed extrasolar origin. The survey system's remarkable ability to rapidly scan vast areas of sky using advanced wide-field imaging technology proved absolutely critical in detecting this extraordinarily rare interstellar visitor amidst the incredibly dense stellar population near the galactic center, where precise object identification remains notoriously challenging. Extensive archival searches later uncovered valuable pre-discovery observational data dating back to June 14th, definitively revealing that this ancient comet had been silently traversing our solar neighborhood for several weeks before achieving formal astronomical recognition and official designation. A stranger in our midst. What makes 3I Atlas truly extraordinary are its unprecedented physical characteristics that, honestly, challenge conventional understanding of interstellar objects. Moving at an absolutely mind-boggling speed of approximately 58 kilometers per second relative to the Sun, this cosmic visitor dramatically outpaces both previous interstellar visitors, Oumuamua and 2I Borisov. Its extreme orbital eccentricity of 6.14 represents the highest value ever recorded for any known celestial object, creating an almost perfectly straight trajectory through our solar system. Initial size estimates suggested the object could measure up to 20 kilometers in diameter, making it potentially the largest interstellar visitor ever observed. though recent Hubble Space Telescope observations indicate a more modest size between 0.32 and 5.6 kilometers. The comet's unusual brightness patterns and early activation, while still 4.5 astronomical units from the Sun, have puzzled researchers worldwide. Unlike typical comets that remain dormant at such distances, 3Y Atlas began displaying cometary activity far earlier than theoretical models predict, suggesting either unique composition or potentially artificial characteristics. Its trajectory alignment with the ecliptic plane occurs with only a 0.2% probability by random chance, raising questions about whether this positioning might be deliberate rather than coincidental, adding another layer of mystery to an already enigmatic cosmic visitor. The predecessors. The discovery of 3I Atlas follows two other remarkable interstellar visitors that, really revolutionized our understanding of cosmic wanderers. Oumuamua, discovered in October 2017 by astronomer Robert Warwick at the University of Hawaii, became the first confirmed interstellar object. It measured roughly 400 meters long and had this unusual elongated shape. Its mysterious acceleration patterns sparked intense scientific debate, with some researchers even proposing exotic explanations including possible artificial origins. 2 years later, amateur astronomer Gennady Borisov discovered 2I Borisov in August 2019, which turned out to be a more conventional interstellar comet with typical outgassing behavior and composition. These three visitors demonstrate that interstellar objects may actually be far more common than we previously believed, with improved detection capabilities now revealing a steady stream of cosmic travelers passing through our solar system. The objects display varying characteristics. Oumuamua appeared asteroid-like with no visible coma. Borisov behaved like a typical comet, while 3I Atlas exhibits these hybrid features that just don't fit established categories perfectly. This progression suggests our solar system regularly encounters material ejected from other stellar systems throughout the galaxy, providing, honestly, unprecedented opportunities to study the composition and formation processes of distant planetary systems, without needing to mount expensive interstellar missions to reach them. The cosmic journey. 3I Atlas follows a precisely calculated path through our solar system that brings it tantalizingly close to multiple planets during its brief visit. The comet will reach perihelion on October 30, 2025, approaching within 1.36 astronomical units of the Sun, positioning it between Earth and Mars at its closest solar approach. During its journey, the object will pass remarkably close to several planets. 0.19 AU from Mars on October 3, 0.65 AU from Venus on November 3, and 1.8 AU from Earth on December 19, 2025. These planetary encounters offer honestly unprecedented scientific opportunities to study an interstellar visitor using various spacecraft instruments and ground-based observatories positioned throughout the solar system. The comet's retrograde orbit, inclined 175 degrees relative to the ecliptic plane, means it travels opposite to the planet's orbital motion, adding to its mysterious nature. Computer models tracking its future trajectory indicate 3I Atlas will eventually pass 0.36 AU from Jupiter on March 16, 2026, before departing our solar system forever. This cosmic journey provides a once-in-a-lifetime opportunity for comprehensive multi-wavelength observations, gravitational studies, and potential spacecraft encounters that could, really unlock secrets about the formation and evolution of planetary systems beyond our own solar neighborhood. A scientific goldmine. The arrival of 3I Atlas presents astronomers with an unprecedented scientific opportunity to study pristine interstellar material using cutting-edge technology that just wasn't available during previous visits. NASA's Hubble Space Telescope captured detailed images in July 2025, revealing the comet's coma structure and dust distribution patterns. The James Webb Space Telescope is conducting comprehensive spectroscopic analysis to determine the object's chemical composition, searching for exotic materials or isotopic ratios that differ from solar system objects. Ground-based observatories worldwide, including the Gemini Observatory and Keck Observatory, are monitoring brightness variations and rotational periods that provide insights into the comet's internal structure and density. Advanced computer modeling allows researchers to simulate the comet's behavior under various theoretical scenarios, testing whether observed characteristics match predictions for natural formation versus artificial construction. International collaboration through organizations like the European Southern Observatory ensures continuous monitoring across multiple wavelengths and time zones. The wealth of data being collected right now far exceeds anything obtained from Oumuamua or Borisov, potentially revolutionizing our understanding of interstellar objects, planetary formation processes, and the dynamic environment between stellar systems. This comprehensive scientific investigation may, hopefully, provide definitive answers about 3I Atlas's true nature and origin before it disappears into interstellar space forever. Unanswered questions. Despite intensive international observation campaigns, 3I Atlas continues to pose fundamental questions that challenge our understanding of interstellar objects and their origins. The comet's exact size remains uncertain due to its surrounding coma of reflective dust, which obscures the nucleus and, complicates accurate diameter measurements. Early estimates range from 1 to 2 kilometers to potentially 20 kilometers across, representing enormous uncertainty that affects calculations of mass, composition, and internal structure. Dr. John Noonan at Auburn University suggests the nucleus is likely on the smaller end of this range, comparable to 2I Borisov, but definitive measurements await future observations. The object's unusual chemical composition, revealed through spectroscopic analysis, contains isotopic ratios that don't match typical solar system materials, raising questions about the stellar environment where it formed billions of years ago. Its remarkably preserved surface state, despite potentially eons of cosmic ray exposure, challenges models of interstellar weathering and erosion processes. The comet's early activation and controlled outgassing patterns differ significantly from known cometary behavior, suggesting either exotic ice compositions or, possibly, artificial regulation mechanisms. Most puzzling is the statistical improbability of its trajectory alignment and planetary encounter sequence, which some researchers argue exceeds reasonable expectations for random cosmic debris, opening discussions about whether 3I Atlas might represent something more deliberate than natural space debris. The alien question. The possibility that 3I Atlas represents artificial technology rather than natural cosmic debris has sparked intense scientific debate, led prominently by Professor Avi Loeb from Harvard University. Loeb, co-founder of the Galileo project dedicated to searching for extraterrestrial technology, co-authored a controversial paper suggesting the object could potentially represent hostile alien technology based on its unusual trajectory and behavioral patterns. His analysis points to the object's statistically improbable path through our solar system, perfect timing for planetary encounters, and controlled thermal emissions as potential evidence of artificial origins rather than random cosmic wandering. However, the majority of mainstream astronomers strongly reject these claims as premature speculation lacking sufficient evidence, emphasizing that natural explanations remain more plausible for all observed characteristics. Critics argue that entertaining artificial hypotheses without definitive proof undermines scientific credibility and promotes unfounded conspiracy theories about extraterrestrial visitation. The debate highlights fundamental questions about scientific methodology when confronting potentially paradigm-shifting discoveries. Should researchers explore all possible explanations regardless of how extraordinary, or maintain conservative approaches that prioritize conventional interpretations? This controversy reflects broader tensions within the astronomical community about balancing open-minded inquiry with rigorous skepticism when studying objects that challenge established models of natural phenomena and cosmic evolution. Observing the visitor. Astronomers worldwide are employing every available technological resource to study 3I Atlas before it fades from observable range forever. NASA's Hubble Space Telescope continues capturing high-resolution images to monitor changes in the comet's coma and potential tail development as it approaches perihelion. The Swift Observatory is measuring water vapor emissions and ultraviolet signatures that provide insights into the comet's internal ice composition and sublimation processes. Ground-based facilities, including the Very Large Telescope in Chile and Mauna Kea observatories in Hawaii, are conducting continuous photometric monitoring to detect brightness variations, rotational periods, and potential outburst events. Radio telescopes, including the Green Bank Observatory, are searching for any electromagnetic emissions that might indicate artificial communication systems or technological signatures hidden within natural thermal radiation. advanced spectroscopic instruments are analyzing the comet's chemical fingerprints across multiple wavelengths, comparing isotopic ratios and molecular compositions with known solar system materials and theoretical predictions for interstellar objects. Amateur astronomers using sophisticated backyard telescopes are contributing valuable time series observations that fill gaps between professional facility scheduling. This unprecedented global observational campaign represents the most comprehensive study ever conducted of an interstellar visitor, potentially providing definitive answers about 3I Atlas's true nature and implications for our understanding of cosmic intelligence and planetary system evolution. Dawn of a new era. The discovery of 3I Atlas marks the beginning of a revolutionary era in interstellar object detection and analysis, fundamentally transforming humanity's understanding of our cosmic environment. Dr. James Davenport emphasizes that upcoming facilities like the Vera Rubin Observatory are expected to revolutionize detection capabilities, with projections estimating dozens to hundreds of similar discoveries during its operational decade. This technological advancement will enable comprehensive statistical studies of interstellar object populations, their frequency, composition, and origins, providing unprecedented insights into galactic dynamics and planetary system evolution throughout the Milky Way. The European Space Agency's JWST spectroscopy division continues developing new analytical techniques specifically designed to distinguish between natural and artificial characteristics in future interstellar visitors, preparing for potential discoveries that might challenge fundamental assumptions about cosmic intelligence. Advanced computer modeling and machine learning algorithms are being developed to rapidly process vast amounts of observational data from multiple sources, identifying subtle patterns and anomalies that might escape human analysis. International cooperation frameworks established during the 3I Atlas investigation will serve as templates for coordinated responses to future discoveries, ensuring maximum scientific return from these rare cosmic opportunities. The broader implications extend beyond astronomy, potentially affecting planetary defense strategies, exobiology research, and humanity's philosophical understanding of our place in a universe that may be far more dynamic and populated than previously imagined. As 3I Atlas continues its journey past the Sun, it leaves behind more questions than answers about the true nature of interstellar visitors. Whether this ancient cosmic wanderer represents natural debris from a distant star system, or something far more extraordinary, its discovery has opened new frontiers in astronomical research. The truth about 3I Atlas may reshape our understanding of intelligence in the cosmos. Keep exploring with Simply Science, like, share, and subscribe for more cosmic revelations.